So we will be doing a lightning talk kind of a session. So I've asked each of the fellows to prepare like a 6 minutes kind of a presentation. So I'll give you guys 1 minute kind of warning after 5 minutes. So, so let's try to stick to the schedule. So initially I would ask Chauvin to start this off with a brief introduction of the program and the expectations.
So if you do computer programming, you're usually starting from 0, right, to index your array. So I'm the 0 fellow. I thought it would be useful to get a bird's view of what we're attempting to do. This is not very systematically prepared because we're literally getting immersed into all the mingling throughout the conference. This is very late last night after reception. I apologize if this is not well organized. But first off, congratulations to all of the fellows. Let's. Very compelling proposals, strong responses to our call for participation, and this is going to 13 institutions for 13 projects coming from 17 fellows. As you could see, well represented geographically across the country. Not on this slide. There's a news press. Next slide, I think. On the CyberGIS Center, and the news site also includes profiles for each fellow, an abstract of what each project intends to do. And this is an evolving source of information. As new information will be coming, we'll try to make this as accessible as quickly as possible. So again, this is very opportunistic coming to this stage of the project. We did not design the scope of each proposed project. And pleasantly surprising, the projects proposed by the fellows cover a quite nice breadth in terms of the different areas, as summarized by this slide. And even more surprisingly, pleasantly surprised is the complementarity across the projects, as you could see. Again, this categorization is my personal attempt to see how these different projects would fit together, and may not be perfect, and some projects do cut across multiple categories, but just showing you the expertise, not only looking at the individual proposals, but also looking at the expertise of the fellows. They're coming to this process, and their aspirations matching to their expertise, not just for education, but hope to also integrate the research they do into the education materials we hope to create for the community. And these are the communities I shared with you the CyberGIS project has engaged. As you could tell, it is very diverse. And that's the nature and the beauty of GIS we all love about, right? There are communities researching and developing CyberGIS itself, but also there are user communities, and some communities cut across, such as geographers and GIS scientists. And I think I could make a safe statement. All of the fellows are interested in advanced digital and spatial studies, have application-oriented angles. So it's application-driven. We want to solve problems. In some cases, real-world problems, and in most cases, scientific problems. And I've shared with you in my first day presentation, we're really having this very diverse, evolving cyber environment with very rich cyber resources, and this was in fact also mentioned by Dan to some degree. So we have a challenge here to expose this evolving cyber infrastructure to the workforce. And in the CyberGIS project, we shared with you, particularly the first day, 3 major thrusts that we need to develop education materials for. These are specific to the CyberGIS project, but I'll show you later this could be broadened to related capabilities and technologies and methodologies. Particular to integration, this is largely going to be coming to the fellow 0 task. This is something I've been doing research for a long time, but I do see some connectivity from the fellows' proposed projects linking to this integration framework. And I look forward to working with the fellows on the integration angle. And there's, in fact, some projects also focused on integration and pedagogy. We have an opportunity to collaborate with industry. This is a diagram really showing the research side, but I think we could learn from the research experimentation coming from this diagram, expand to education. And one particular effort I want to mention, this is most recent sharing coming from Steve and S3 colleagues. I learned this is a very interesting development focusing on LearnGIS, and you see very provocative statement on the page there, and I encourage you to go to that site to explore. Seem to be very interactive and engaging. We have started preparing online mechanisms and collaboration mechanisms for organizing education materials. As I showed you the first day, the wiki page associated with the tools, online tools in particular, this is on a wiki page, and some of us already discussed how to enter into the CyberGIS world. This is one example, and it's based on wiki. That means all of the fellows, not necessarily this specific instance of wiki, but we plan to establish a wiki instance dedicated to CyberGIS education collaboration for the fellows. So we still need to discuss the process of converging to ready-to-use education materials, because a wiki itself, although it's a collaborative mechanism, it doesn't regulate that necessarily. So I think the next session after the fellows' presentations, we have a discussion and a consensus building to understand what is the best and optimal process to regulate the coordination. Not imposing, but bottom up as much as possible. And another preparation we've done, and we actually did internal experimentation, there's this so there's learning resources for CyberGIS education. This has already getting started with some planning materials, and you could also see the feedback. Now it's developed primarily for the research part of CyberGIS Gateway, but I don't think it's necessarily restricted to research. It could be also tailored to education materials evolution. On the toolkit side, this is what I argued to be the resource for data and computational scientists in the CyberGIS context. You could get into here and see the script, see the codes, and see how to download and the user documentation. In some cases, such as TauDim, we directly point to GitHub. So this is an environment I see some fellows proposed high-performance computing angles. We expect this to be growing and expanded and introduce, for instance, how to enter into this toolkit world. And we understand that there are tremendous opportunities here. So with that, thank you all, the fellows, for your aspirations and for your vision to come forward at this stage of the CyberGIS development and research, and I believe is so exciting. I even become too excited sometimes, certainly biased to some degree, but and of course our sponsors. Not only for this conference, I think I see a tremendous opportunity for industry and academia. In fact, the question asked earlier, Dan was alluded to. I think the CyberGIS community is very well positioned to leverage academia, government, and industry resources to work on workforce development. With that, I'll transition to Anand and the CyberGIS Fellows presentation.
Thank you. We'll go to PDF first and then we'll go to the PPTs after that. So what I would ask the fellows is to come up here when your slide's up and introduce yourself and go through your 6 minutes talk. So I have created a single slide with all your presentation except for one. So we'll start with the one which is not there, and then we'll go through the PDFs, PPTs. That's it.
I'll be remembered as the one who doesn't use PowerPoint. Yeah.
What's up, guys? Oh, okay. Sorry, I'm trying to move on already.
Okay. Yeah, sorry about that. I use latex. So my name is Guido Cervone. I'm an associate professor at Penn State. The title of my talk is, or my project, CyberGIS' approach to using remote sensing and social media to assess environmental hazards. I will talk a little bit about the motivation, the process, and the outcome. As a motivation, it's what we've been talking for the last few days, this revolution in science that we're witnessing. For the last 3 centuries, all science has advanced through observation, theory development, experimentation. Last 3 decades, about just 30 years ago, something completely revolutionary happened, this computational-enabled research. And about 10 years ago, we gave it a name, cyber science. And this word cyber has tremendous, far-reaching repercussions in many of the things we do, both in the science and in the engineering and also in the humanities. This has been transformative, will continue to change how we do science. And at Penn State, just last year, we started a new effort, this Institute for Cyber Science. I'm very fortunate to be the associate director of this institute. So far it's small, only 20 faculties, but the plan is to have 100 faculties in the next 6 years. So we will be hiring about 20 faculties a year. And just to tell you how important this is, I just went to the NSF website and I did time-constrained search. I was just curious. I mean, how many times does NSF talk about cyber? And as you can see, this is an exponential growth. I actually interpolated on the last bar. I've done this last week. But this is just, but this is just to say, this is important. This is here to stay. It's important for the funding opportunities. It is important to teach our students how to respond to those new challenges. And it is a very exciting time. And this is because in the history of our civilization, we have never known so much about the planet. We had never had such an easy access to the most disparate data, and never our society has been so much at risk. In 6 minutes, I cannot go over it, but please do trust me that our society is more at risk now than ever it has been. So what we really need some teaching tools in order to present those new challenges and tell the future scientists how to address them. And this is good, it is for the good of our entire civilization. The process, how do we do that? Or at least how I hope to contribute to improve the world a little bit. First of all, remote sensing. I'm a remote sensing person, and remote sensing I use widely. Every time there is a natural disaster anywhere on the planet, we go to remote sensing. However, we do have some problems that we have first revisiting times. Remote sensing instruments are not always when we want them and where we want them, even if we use multiple instruments. And then we have the problem with the atmosphere. We have to look through the atmosphere, and sometimes it's just opaque. It will not allow us to do an assessment of what is happening. So a solution is trying to leverage this new class of data, social media, in order to fill those gaps in our remote sensing data. It is a data fusion problem. We have remote sensing with very high spatial resolution but low temporal resolution, and social media that conversely has a low spatial resolution but very high temporal resolution, is a data stream. And the plan is to try to augment those initial satellite observation with those new ground information and to teach students how to do it. This is an initial work that I've done with my PhD student, was published last year. We combined different remote sensing data with, this was USGS Landsat. We combined them with tweets, photos, videos, and so on. And we were able to do a real-time damage assessment. We could actually show how this flood was moving over time, something that we couldn't do just from two Landsat images. And the outcome that I hope to be able to share with everyone is a QuantumGIS plugin. And I'm saying this here at the S3, that I will be using QuantumGIS. But this is a QuantumGIS plugin that will leverage different CyberGIS technologies. We'll be able to query for different tweets, do the analysis offline, and bring it into a desktop where the students will be able to automatically fuse this incoming data with remote sensing data, which is already part of QuantumGIS. So this is, just to conclude, this is an image that one of my students did. I just asked him, please take an image for, this is Penn State, for State College, just overplot a few tweets on it. It told him that it took about 20 minutes to do this. I hope that this will be able to be done instantaneously. And this is my talk. Thank you.
Thank you so much.
Good morning. I'm Shakil Kashim. I'm a doctoral candidate at the Department of Urban Region Planning in University of Illinois, Urbana-Champaign. For our work, actually, Professor Bev Wilson is with me, but he's not here today, so I'm kind of here to tell what we are planning to do for our fellow program. So our motivation for this work is that in planning, actually, in urban planning, we are using GIS for a long time, but we are not aware that much about the CyberGIS infrastructure and the capabilities. We are still relying more on these desktop-based programs, and the reason is inadequacy of education materials. We are not having that much education material that will aware our planners and researchers on CyberGIS capabilities, and also we are having any don't have any scope for training for that. So right now in our department, we are having these two GIS courses. One is GIS for Planners, EP418. It's simply kind of introductory course on GIS. It's showing basic mapping techniques and how to do some simple analysis. And there is an advanced GIS application. It's how to do a little bit on how simply spatial econometrics, some image analysis, this kind of advanced applications. So our plan is to develop one lecture and two lab modules for each of these courses, and to aware our students about the CyberGIS capabilities. For the introductory course, our lecture will simply introduce our students to basic mechanisms of CyberGIS, or what are the present state of technology, how in urban planning we can use CyberGIS capabilities, and how big data can be used. So simply basic introduction to those issues, because our target audience in this case is the undergrads and some early stage graduate students. So, and our lab, since this course will focus mainly on data visualization and do some simple analysis, one of the lab will be focused on how to do data visualization using CyberGIS infrastructure. And the second lab will be multiple criteria analysis. Right now we have one lab on that, how to integrate different decision layers and how to come up with some kind of suitability analysis. So how to do that in CyberGIS environment. And in our second course, the Advanced GIS course, we will go a little bit deeper on CyberGIS infrastructure and the capabilities and what is the fundamentals and principles of CyberGIS, how to work with big data, a little bit more on these issues, and what is the CyberGIS toolkits we are having, and what are the latest technologies are developing in those areas. In the labs, we are planning to kind of convert our existing labs on that is focusing on spatial regression or spatial econometrics, how to do it in CyberGIS environment. And another lab will be working in the CyberGIS toolkit. So with these learning modules, we are expecting that at the end, we will create a group of CyberGIS enthusiast practitioners and researchers. So right now, we are having students coming from all over the campus to our GIS classes. So if we can just inform them about these CyberGIS capabilities, so we hope that at the end, some of them will be going for being a kind of CyberGIS scientist. Sometime they will go for CyberGIS user. So that's our broad expectation from this program. And particularly thanks Shawn and CyberGIS community to give us this opportunity to be here. It's very exciting for us, and we actually learned a lot from this last 2 days of the programs. Thank you.
Hello everyone. I'm Chun Huang from the Department of Geography in University of Wisconsin-Madison. Well, this is my proposal developing CyberGIS education curriculum. This is a little bit big, I feel like that. So this outline like everybody else. My motivation to submit the proposal actually have several reasons. The first one is in the past several years, actually, with the advancement of web, internet, hardware, and software, we actually witnessed the shift of traditional GIS problems to CyberGIS problems. For example, from desktop to online problems that require fast and quick response, small-scale to large-scale problems that needed to leverage multi-source data and distribute computing power, from simple geoprocess to complex and computational-intensive problems that needed to integrate high-performance computing capabilities, as well as finally stand-alone problems to collaborate problems that needed to leverage knowledge from multiple domains. On the same time that most of our students, even educators, have not adapted to such shift, not fully prepared for such change. And finally, CyberGIS incorporate a wide range of topics and techniques, as well as that those topics cannot cover in a single course. And the sequence of the topics and the techniques, how we should educate our students, could be very tricky and challenging, just posted by Professor Mayan the other day. So my objective for this proposal is develop a face-by-face curriculum to educate our next generation, help them prepare for their future career, as well as serve as guidance or reference for the educate while they teach the students in the topics and the techniques related to CyberGIS. So how can we achieve such an object? And first, let's look at typical CyberGIS system architecture. This is a layer-based architecture. Let's look from the bottom to up. First, we have a data layer. The data could be stored in distributed file systems such as Google distributed file system, Hadoop distributed file system, and network file system. And also the data could be directly served as a standardized service such as WMS, WCS. Of course, data mostly managed and organized in right now traditional database, but more and more often data, especially social media data, are most organized in the non-SQL database, such as MongoDB. Above that, we have a computing infrastructure layer that could be built based on different computing models, such as cluster computing, grid cloud, GPU, citizen, or MIC computing. So different computing infrastructure have a different program model, like MPI, OpenMPI, and MapReduce. Above that, this is our core layer. That also is the most difficult layer while we educate the students, is middleware or gateway. So we have two components. First component is computing middleware. This middleware is provide the capability like organize, manage underlying computing resource, and also provide the capability of scheduling the task and collect the result. Special middleware, this is our core component in CyberGIS. One example is GIS'14. So this special middleware would provide our core component about spatial analysis, spatial modeling, and also geospatial processing component functions. I think the figure presented by Xiaowen include all very detailed description about those components. Above that is a special web portal that can be accessed by public different community scientists to utilize the portal to access underlying computing power and the spatial GIS function. So look, based on this architecture, I propose 3 courses. And each course will focus on different GIS concept and techniques. So the first course I suggest is techniques in CyberGIS. This is the most fundamental and the easiest course that we should targeting both undergraduate and graduate students. Basically, this course would be an icebreaker course in CyberGIS, provide the foundation for the next level course. And this course should teach and train the skills of students in something like developing special web portal or mobile application for different domain science. So the component in this course would be something program skills, web developer, mobile developer skills. And the next layer, I think is relatively intuitive to teach is the spatial database. And this layer would introduce spatial data, spatial database, design and implementation, as well as put some effort on teaching the latest database like non-SQL database. And finally, the CyberGIS layer, this would be a high-level graduate student course. So this layer will teach the students related spatial middleware as well as the computing infrastructure about different computing model, different program model. So finally, the deliverable, I would outline the topics for each course. And since this is a technical-oriented course, so lab is a very important component for such course. So I will come up a list of labs for each course and develop some key labs, as well as I will look into the lab to look for the available good examples and tutorials for related topics. And finally, each course should have recommended readings and textbook for each related topics. Well, thank you.
Hello, everyone. My name is Wenwen Li. I'm assistant professor at Arizona State University. Today, I will introduce my plan to develop a new undergraduate course at ASU on Introduction to Service-Oriented CyberGIS Science. So before I start, I would like to give you a little bit background introduction about why I'm interested in this project and why I think this project is important to the CyberGIS education. So I'm a cyber infrastructure researcher. I have been conducting cyber infrastructure research since my PhD. And after joining ASU, I have got the chance to participate in the CyberGIS project, in which I have gained much experience in the research and development of CyberGIS. So thanks to my colleagues and thanks, Xiaowen. And also, as another activity, I am leading a small NSF project on building a service-oriented cyber infrastructure to support domain science, the polar science. And this project emphasizes the data aspect of cyber infrastructure by improving or maximizing the accessibility of the distributed geospatial resources scattered on the cyberspace through large-scale web mining. And as another trend of education, since joining ASU, I have offered a number of the GIS courses, and I have also given a cyber infrastructure graduate seminar in which my student and myself have investigated a number of the recent advancements in cyber infrastructure research, including data access, realization, high-performance computing, as well as the community-driven approach. And at ASU, we recently have approved a new GIS science degree, the undergraduate degree, and we are offering a series of new courses in terms of spatial thinking, data structure, and database. I think these three courses serves as a very nice prerequisite for the service-oriented cyber GIS science course. In terms of the pedagogy, the first one is I will emphasize the hands-on experience because I believe this one is very important to almost all of the GIS education. And the second one is reinforcement learning. So I hope in the class, the lectures will be set with enough overlap so the students can review what has learned in the previous lecture. And we'll also introduce new stuff, so to gradually build the knowledge base of CyberGIS to the students. The last point I want to emphasize is the computational spatial thinking skills. The current GIS education has trained a lot of the spatial thinkers. Well, I believe that computational thinking skills is also very important. For example, to arrive to this magic land of science, and we need to build a gigantic boat. Maybe it's a CyberGIS boat, but it's more than a tool itself. I think there are a lot of the interesting research topics that deserves investigating. For example, interoperability, the interoperability between different heterogeneous data, heterogeneous software packages, and heterogeneous CyberGIS systems. And another is semantics. So semantic ambiguation is ubiquitous in almost all kinds of information. So resolving these semantic issues will help effective information representation, organization, and retrieval. The third one is data access. So we have huge data, right, scattered on the cyberspace. How can we improve the access of these distributed data resources? And the provenance that we have discussed a little bit, which ensures the science reproductivity, is another important topic. And cloud and parallel computing, which is a major theme of this conference, we have enough aware of this importance. So understanding all these research topics requires computational thinking skills. And combining the computational thinking and the spatial thinking, I think we can solve the geospatial problem more efficiently and more effectively. And this is the content of this new course. So the concept and series I have introduced a little bit in my last slide. And in terms of technique, we will learn new programming languages and software packages. But as Dr. Guchel has mentioned, the techniques is evolving so fast that before a student masters a tool, it may already got obsolete. So in this class, instead of sticking with one software package, I will try to help the student to gain the problem-solving skills so they can have the ability to solve a problem very effectively after the class. And the last one is application, and I will introduce a little bit in my later slides. And the one thing I want to emphasize is to bring the research into education. And both of these two topics are the very exciting thing in my life. So for example, in the earlier GIS courses, the students always ask me, where can I get this data? Like, where can I get the USGS data? Where can I get the sensors data for my final project? And based on this NSF project, my team at ASU has built a Polar Hub. It's a large-scale web crawling to discover the distributed geospatial resources. Though using this cyber infrastructure platform, the students can get onto this operational system, find the information they want, and to conduct this research. At the same time, they can experience what cyber infrastructure can bring to them and how the cyber infrastructure can benefit their research. Another example is a cyber infrastructure portal we built that uses service-oriented integration. So we can, for example, grab the population data from Colombia and then another data layer from Germany to show what are the relationship between population and environment. And here's another example. The students can grab the earthquake data in real time from USGS and to conduct the spatial temporal animation of this data across the world. The last slide is to support the snow scientists to conduct the snow volume computation based on the time series of data stored in the cyber infrastructure. So based on the experience of this cyber infrastructure, the students can use it, experience the new technique, and learn the new technique in the class, and eventually become a cyber scientist themselves. The very last point I want to make is a community-driven approach. I would like to closely collaborate with other CyberGIS fellows to develop a sustainable CyberGIS curriculum to support the education of our next generation CyberGIS workforce. Thank you.
Dawn, David, you're going to have to help me out here. You guys know what to do. Howdy. All right, that's what we do at A&M to start everything. All right, let's try that again. Howdy. There you go. All right, so my name is Dan Goldberg. I'm from Texas A&M University. I'm in the Department of Geography as my 10-year home, but I also have an appointment in the Department of Computer Science. And first things first, on behalf of myself and Serge, I would like to just lodge a formal complaint about the disparaging remarks made about the great state of New Jersey yesterday. At least it's not Texas. Oh, wait. So my project is somewhat of a meta project, which links a lot of the other projects together. And it's based on three main problems. So my career as a student and as an academic has gone from the right to the left. So all of my training, undergrad, master's, and PhD, were all in computer science. And I've made my way through CyberGIS, not realizing that I was doing CyberGIS, into GIS. So I'm now primarily homed in a Department of Geography teaching GIS. So I'm trying to figure out how we go the other direction, right? So in most programs, these two fields are completely separate. Students in geography will take 1 or 2 computer science classes. Students in computer science hardly, if ever, take classes in geography. So that leads us to a bunch of problems. What I have come to realize in my introduction to GIS programming classes is that there is a large amount of, I would say, unfounded phobia by geography students. So they would look at something like this and just see tons and tons of words, semicolons, brackets they've never seen before, and just get scared out of their minds, want to run and hide. So what that does is it means that most geography and GIS students wait until the very end of their undergraduate career before they take their first required computer science class. You know, it's usually an intro to Java or Python class. They wait until the last semester, last possible time it could be done to take it in their undergrad degree. which means that they haven't learned how to do CyberGIS, because I would argue that the very first thing you need to know to go from GIS to CyberGIS is how to program. That is the absolute basic thing that you need to know. So the additional problem, which are / opportunity, is that in many fields, particularly learning science, there is an entire body of literature about how people learn, the best ways to develop and deliver material to these people. I've been fortunate in my life to have worked with heavyweights in geo-ed, specifically Karen right here, 2 of my new colleagues at A&M, Bob and Sarah Bednars, and through relationships with UCGIS, particularly Diana Sinton, I've come to know and begin to appreciate GIS education. And it's not an area that I'm a super expert in, but it's an area that I'm really excited about. So there is tons and tons and tons of existing literature and theory and application and practice and assessments out there across all of these different fields. So learning science in general, geographic education in general, GIS education, and as we saw earlier this morning, computer science education. But because CyberGIS is relatively new, brand spanking new, I would argue, critical assessments of effectively teaching computer science to geography and GIS students are lacking. So my project is to survey the community, so all of you here today, as well as the broader community who couldn't be with us, to actually go out and gather information about how people teach, what they teach, how they actually deliver it in class. So do you write it on the board? Do you type it in real time? Or do you present it as lecture notes? I've done all 3. And some students love it, some students hate it. It's very much about the ways that people learn. So go out and get the actual teaching materials, which include the syllabus for your course, anything you would be able and willing to share with me, so your actual lecture notes, your assignments, your labs, some examples of what student projects and homework assignments would be, exams, and then take all of those materials, synthesize them together, and figure out through surveys with you and hopefully your students what worked and what didn't work, and then try to tease out why it was. So the point of that would be to come up with best practices and lessons learned that we can share with the community. Because how many of us in here teach intro to programming of some kind for GIS or geography students? Right? We all should be leveraging the knowledge which we've come to grasp from our experiences teaching it. So the primary purpose of this project is to begin to synthesize all of that together and then distribute it. So make it available. The code carpentry model that I learned about for the very first time at this meeting I think is awesome. And sharing these materials will make it easier for everyone. Right? So we want to develop model curricula including everything that we could possibly do in the classroom, come up with what works, what doesn't work, and then make it available, and then rinse and repeat. So I see this very much, like the last presenter, as a community-driven effort. I know what I know. I don't know what I don't know. So I need experiences and materials and perceptions from all of you and hopefully your students to figure out how to do this properly. So the approach, I'm going to make a request for participation and materials. So I'm requesting each of you to participate and provide me any materials which you would be willing to share, even just the syllabus. You know, those are generally posted online, open access at your university anyway. But if you wanted to get more involved with the project, I would love it if you would give me everything that you can. I'm happy to share all of my materials with you. In my 4 semesters at A&M now, I've had to do a ton of new preps, and I know that it is not fun. So if anybody needs these materials, I have Intro to Web Programming, Intro to GIS Programming, so Python and C#, as well as an Intro to Spatial Database Programming class that I'd be very happy to share with anyone. We're going to then go through all of those materials, try to do a systematic, objective review. I'm looking at Karen here, so I'm hoping that you're going to help some of this. Figure out what people are doing the same, what they're doing different, and then do interviews to figure out what is working and what's not working. And I'd like to interview each of you for your experiences as well as your students. So this is on its way through IRB at A&M, so human subjects will be protected. And then using all of that information, both qualitative, quantitative, synthesize it together and come up with just what people are doing in general. And I like the recipes for success and disaster. So what has worked really, really well and what has failed miserably. I've had both of them, and I'm sure you all have as well. Reporting and publication, so brand new assistant professor up here, #1 thing I need to do is publish. I realize that everything which you develop is either the intellectual property of you, your university, your TAs, some combination of all of that. So a goal of the CyberGIS project, as I understand it, is to make information openly accessible. So it's still to be determined what the best method and appropriate method to both publish about it and distribute it is. So that's hopefully something that I can talk, or that I hope we will talk about that in the next session after this, because I think it's very important, because all of us in this room have spent countless hours developing really, really nice and thoughtful exercises, and you should get credit for that. And then hopefully do some pilot testing, maybe some case control studies or some cohort studies to understand how this is actually impacting student learning, and ultimately taking GIS students and moving them to become CyberGI scientists. And then I want to do similar projects to go the other way around. So thank you.
Hi, so I'm Mark McKinney. I'm from Southern Illinois University, Edwardsville. I'm an assistant professor there. And my project is education modules for integration with existing undergraduate curricula. So we've got this problem, at least in my department, so I'm from the computer science side of things. I've got all these students who come by and want to know about spatial concepts, about geo concepts, CyberGIS, things like that. But our curriculum is incredibly full, right? So we're actually in the process of trying to get rid of credits at this point. We've been told we have too many. So we don't have room to introduce new classes or things like this. So the idea was that we could create some standalone modules that instructors could just incorporate into courses wherever they're relevant and wherever they can do this sort of thing. So this was a little bit of a practical project, right? I need to do this for my own courses to get these students up to speed, to satisfy their curiosity when they hear things about spatial applications and things like this, and also prepare them for the workforce. So I basically posed 3 modules that seem to encompass a lot of what students are voicing to me, that what they want to know and what are important, I think. And the first one is the big data concepts module. So the idea behind these is to use sort of freely available software and freely available data, so that once I put all this stuff together and put it out there, anybody can just take this and with a very minimal time investment set it up to use for a class if they want to, or use for projects and things like this. So the first one is using airline on-time statistics. This is just freely available data from the US Department of Transportation. It's pretty intuitive data, right? It's basically organized by airport and airline, and you basically see the delays for different airlines, different airports at different times and things like this. And it makes sense, right? So when you start looking for the airports that have the most delays, it's the biggest airports because they have the most planes that come in. So when you're doing queries and things like this, it's students can see that they're getting the right answers for sort of the basic stuff. And I'm doing this with a Mongo database because it takes less than 2 seconds to install, and then it's there. So we can do MapReduce, we can do all these types of things in a very hands-on fashion with sort of limited startup time. And it scales. If you can do a MapReduce on Mongo database, you can do a MapReduce on anything, right? It's sort of a simple paradigm there. So the module itself will have some intros to the big data architecture, right? Go over Google file system and Hadoop and things like this, and then of course have hands-on exercises. So some worked out, and then challenges for the students to actually explore as well. The next module, so that one I kind of work into database classes and things like that. The next one is GPU computing. I've got a lot of interest in this from a lot of students, and this one is a little bit tougher, right? If you've ever learned how to do GPU computing, you probably know that there's not a lot of good intro material out there, or at least there wasn't when I was learning this not too long ago. So there's the CUDA programming guide, which, you know, the examples in there are not the easiest to follow, and if someone's just brand new to this, it's pretty tough. So the idea is to, you know, basically you need a CUDA-enabled GPU to do this module, because you got to run it somewhere. But that's a minimal investment. I mean, a lot of computers just come with that these days. So the idea is it's just an introduction to sort of the architecture, the programming model, the threading model. And basically, when I've tried to do this in classes, I found the easiest way is just to come up with a dead simple program and, you know, show the serial version, show the basic GPU version, and then you can sort of walk through it, and you can walk through the changes very easily because it's a very short program. So you can start talking about memory, architecture in the GPU, and then, you know, shared memory, things like this, and then make the changes to show the students how it works. At the end, right, once you've got this basic stuff, you then sort of turn the students loose on a more challenging problem. So in this case, you know, there's some work on overlay computations and things like that with vector data that, you know, I'll probably use as the example there. But of course, if anybody has suggestions, they can always add more examples as well. And the last one is a little bit of sort of an interactive module. Right, so there's this data set put out by the National Weather Service that has hurricane descriptions for the past 20 years. The basic idea is that you have snapshots of hurricane extents. So it's the region the hurricane was covering at 12 o'clock, and then at 6 o'clock, and then at, you know, 8 o'clock. And we've taken this and sort of interpolated it into 3 dimensions. So you've got these nice moving regions. And then the question is, you know, what can you actually ask about this? So it's a pretty intuitive data set. Again, people usually understand hurricanes. You can throw out some nice questions like, you know, where do the most hurricanes tend to overlap and things like this. And then you can start talking about using these other modules to sort of compute this type of thing. So it's a little bit more of an interactive module, and students can come up with some interesting questions. So these were the goals that I proposed, and hopefully you guys will find them interesting and be able to use some of them. And thank you.
Good morning, everyone. My name is Yi Qiang. I'm from Louisiana State University. I work with Dr. Nina Lam for this fellow project. And we are trying to use CyberGIS to model the coupled natural and the human dynamics in coastal Louisiana. Our project is a little bit different from the others. Our project is more application-driven. But we do believe that application may provide special value to education because whatever you teach, you need use case, you need lab exercise to let your student know how CyberGIS can solve real-world problems. Let me start from some background information. As you know, that Louisiana is one of the most vulnerable coasts in continental USA. Over the years, it has endured multiple threats like hurricanes, land loss, flood, and oil spills. And probably because of these threats, there's a gradual population and economic growth has been observed in the northern part of Louisiana in contrast with the decline in the south. So there are 2 critical questions has put forward. Will the southern Louisiana become too costly to sustain? Will the same socioeconomic and ecological service gradually migrate from the south to the north? After putting considerable effort to save the coast, people have realized that the interaction between human and the natural system is the key to solve these sustainability issues. And 2 years ago, Dr. Lam and a number of LSU researchers has initiated a project to model the coupled natural and human dynamics in coastal Louisiana. This project is funded by NSF as well. It includes 7 components that covering socioeconomic, ecology, hydrology, energy, and the government aspects. And the goal of this project is to evaluate long-term sustainability in coastal Louisiana and the funding paths to leverage the sustainability in this region. And in the research process, that we found that the computational powers of ordinary desktop PC becomes a bottleneck, because first, many of our data sets are from satellite images, so we define a spatial resolution, 30 meter by 30 meter, which results in a large number of pixels for just a single data layer. And then the overall data set becomes huge when the model includes multiple data layers. And also, agent-based modeling in such a large area is also a computational challenge because of large agent population size. And some rules and the function parameters need to be calibrated using heuristic algorithm like genetic algorithm neural network from a large sample set, which is also compute intensive. And finally, the model is a dynamic model, includes a number of agent-based model and the cellular automata that runs iteratively to simulate scenarios in a long time period. All of these characteristics makes a CNH model beyond the capacity of common sequential computing facilities. We have been looking for high-performance computing solutions to overcome these issues, and we found the idea of CyberGIS perfect fit our situation, can benefit our research from many aspects. First, the supercomputer-enabled infrastructure can effectively tackle the data and the computing intensive modeling task in our research. And also the CyberGIS is a collaborative platform that includes many application and toolkits developed by other GIS practitioners, which we can directly reuse for our model development. And it also has very good interoperability with other GIS platforms and data providers that can enrich our modeling resource. And also the service-oriented architecture of CyberGIS is particularly suitable for multi-component environment models like our CNH model, because the model component can be deployed as web services for flexible chaining and interoperation. And also the web-based and the loosely coupled structure can facilitate publication, reuse, and sharing of our environment models. Our research will deliver both research and teaching outcomes. I know that Xiaowen only wants research outcomes, but only want teaching materials, but I think research outcomes is good byproducts of our project. First of all, we are trying to answer the following research questions. How can CyberGIS benefit traditional environmental science and sustainability science? What is the best way to implement the multi-component environment models like our CNH model in the CyberGIS environments? And how can the development model be better shared with a broader range of researchers, stakeholders, and even the public through the web? And the more fundamental question is how to formalize the model semantics and derive the knowledge in a way to achieve more efficient interoperation and integration. Because for the moment, all the data knowledge and data are kept in scientific articles, which is very difficult to abstract and program in a computer program, which we think is the major barrier is semantic. And our project includes a few major tasks. First, we will implement the model component as web services in CyberGIS environments, and we will calibrate our model using optimization toolkits in CyberGIS, or we develop ad hoc algorithm to calibrate our model. And we also need to validate our model to make sure it reflects the real-world process, and also design user interfaces and the service interface to allow better interoperability. Finally, the research outcome will be published in scientific journals and conferences. Meanwhile, we will develop teaching materials based on the knowledge derived from the research part. The first step, we will include CyberGIS topics in our existing courses in the Department of Environmental Sciences at LSU. And we will encourage our co-PIs to also introduce the idea of CyberGIS to other departments in LSU. And we will develop lab exercise based on some components of the CNH model to give students a sense how CyberGIS can help people to solve real-world problems. And in our long-term plan, we plan to develop teaching materials of a semester-long courses to teach serious topics like CyberGIS, WebGIS, and geocomputation in general. And besides this, we will conduct seminars and workshops in LSU to introduce the concept of CyberGIS to more LSU students and faculties. And also presentation will be given in local conference to introduce CyberGIS to the local research communities in Louisiana to solve the research questions in Louisiana context. I think that's all of my presentation. Thank you for your attention.
Hi, I'm here presenting on behalf of myself and my new colleague, Jim Thatcher. I just finished my PhD like last week, and I will be starting this new position in the fall. So first, I want to ask you, who are the end users of CyberGIS? Do you have an image in your mind? I would argue the lowest common denominator, anyone who has access to a smartphone and is using location-based services. As Goodchild early on pointed out, this is an opportunity. So one person's zombie apocalypse is another community's really exciting opportunity to collect and disseminate information to disperse populations. So with this in mind, who are the builders of CyberGIS or the users? So we're in a really interesting position. Many people have already pointed this out. So that's us, the researchers. We're figuring out how CyberGIS is being the architecture and how to build it, while we're simultaneously teaching our students about CyberGIS. So we're in a really interesting position, and it's really comforting to have you all here in this position with me. So how do we translate data into information and then disseminate it to the population? And this is really the question we need to be asking as we're coming up with these technological solutions. And we really need to instill this in our students as well, this idea of critical thinking. And these are questions I have, and I've talked to many of the other fellows and many of you in this room, and I think, again, it's oddly comforting that I know you all have the same questions. So what tools are available? Well, we're seeing that this landscape is changing rapidly. The dust hasn't settled, and there are new tools emerging every day. So this is really, really difficult to stay on top of, along with our other responsibilities as academics. So what tools are available? Which ones do we teach? What jobs are the students targeting? And how do we develop curriculum to prepare these students for these new jobs that are emerging? Given that more and more people have access to these tools, we're seeing that there are more jobs and there is more opportunity for our students. But this is extremely overwhelming, these very big questions. So to help me kind of break things down, I've tried to think about, okay, there are different types of CyberGIS students. So it was really good chatting with Dan because he did, that Venn diagram was awesome. So he's coming from the computer science side of the spectrum. So now I'm going to reveal my positionality. I'm coming from the geography side of the spectrum, moving into computer science. So I kind of came up with these different levels. There are these levels of geographers who are interested, whether they know it or not. These zombies might, when they're tapping into CyberGIS, they might not know they're using CyberGIS, but they might be having a great time and loving using CyberGIS. So first, let's look at level one, the base of the pyramid, the basic user. Or the expert user of the output, so they might be really comfortable in Google Earth and zipping around Google Maps, but they're a basic user of GIS. And this is kind of what I would call the gateway drug, perhaps. This is a way to hook those geographers who say, I don't want to code, I don't want to program, but you can show them, hey, if you change one lat long, look what happens. The second level would be perhaps considered the traditional GIS student. And like we said, this is a very established level that we've gone over for years, but now we're doing more of these functionality on the web and in cyberspace. And then the third level is what most of the research here has been covering, really the expert user, the CyberGIS user who really understands or needs to understand the infrastructure involved in keeping CyberGIS going and moving forward and all the different levels. So this is kind of how I've been breaking down my teaching load and my course modules. I'm developing courses geared towards level 1, so using tools such as Google Earth, ArcGIS Online, and the very user-friendly GUI applications. Level 2 would be doing more spatial analysis, and then level 3 would be setting up Arc Server and really integrating the front and the back end of CyberGIS and introducing students to those concepts. So for the deliverables for this initiative, Jim and I are going to be sharing all of our course materials and sharing our experiences collectively with all of you guys. And we've also been invited to come up with like the intro labs for public health and criminology in different universities. And I think what's happening is that, you know, physical geography, human geography, and other domains know that, you know what, you can take a spreadsheet, click 2 buttons, and if there's locational information, you can have an interactive map. And this is what they want to teach those students. So these are what I would be considering level 1 course material. Additionally, so the Department of Urban Studies at University of Washington Tacoma is this year starting a course-based 1-year master's program. And so I'll be teaching Intro to Geospatial Technology and CyberGIS. And Intro to Geospatial Technology, I plan to make course material level 1, 2, and 3 because this is one of the first courses they'll be taking in this master's. And then CyberGIS will be primarily level 2 and 3, and then Jim will be teaching the final two courses. So we'll be sharing that. And then also, I had one slide. I wanted to share the idea of perhaps having a collective journal. Like you already have interviews. Dan already has shared ideas. I'm looking forward to Karen's talk as well. But maybe collective journaling, because it's really apparent that our individual epistemological backgrounds is really going to influence how we develop our course material. So sharing these experiences, documenting them as they're happening, and then maybe peer coding these responses, I feel like we would learn so much from each other. And I am just so honored to be a part of this cohort and looking forward to working with all of you this year. And then another idea is for the level 3. I'm thinking about not using the UW system, what is it called? Web homework system. What is that called? Blackboard or whatever. And instead using GitHub. And there's been a movement to use this as the way of turning in your course material, and I think it would just teach students good practice to get used to using GitHub for their workflow. So thank you very much for having us.
So my name is Eric Shook, and I'm from the Department of Geography at Kent State University. And the title of my fellow proposal was CyberGIS Education from the Bottom Up. And this was really inspired by a special topics course in CyberGIS that I taught in the spring semester. It's a relatively small course consisting of 3 PhD, 1 master, and 1 undergraduate student. Yes, I said undergraduate student. It actually consisted of a mix of business and geography students, and it had a fairly broad focus. I looked at CyberGIS and related geospatial technologies with these students, and unfortunately, I didn't incorporate any parallel spatial data processing. I found it was often too difficult to really introduce parallel processing, given the currently available tools. Somebody was talking about that already, and the given curriculum. How do we actually incorporate this into our class? And that's really the fundamental question that I had to ask myself, and this was actually even before the fellows material or solicitation was out there, is how do we actually introduce parallel spatial data processing, not only to geographers, but other fledgling CyberGIS scientists, right? So I had the business students, we have the computer science students, we have, you know, the ecologists, et cetera, right? And my argument is from the bottom up. You really have to start where the students are at. You can't talk at a level up here if the students are all at a level down here in terms of technology. And that's not necessarily a bad thing. We just need to build them up, right? So looking around, I can't think of a better framework than cartographic modeling framework. I know I harped on this a little bit yesterday, but I really think that it works well, primarily because it's already in the GIS curriculum, right? So intro and advanced GIS courses, not only at Kent State, but across the US and arguably across the world, all teach cartographic modeling because it's an elegant and powerful conceptual framework for spatial data processing. So I overviewed it a little bit, but for those of you who were out at coffee during my talk yesterday, it's set up generally, a user will set up a procedure as a sequence of operations. The operations all do different data manipulations, different calculations, and you can put these in different configurations as a computational workflow from the computational sciences perspective in order to look at the data in different perspectives, right? And this is how we really build our understanding. So from that, and I appreciate the compliment on the language, I've been working in a collaborative project on the parallel cartographic modeling language. In computer science terms, it's a domain-specific language designed specifically for CyberGIS. It extends cartographic modeling, the bits in the black, with a number of parallel concepts that can be overridden by developers and users, including a parallel scheduler, decomposition, iteration, and subdomains that act as the elemental unit of parallel computation. So we're talking about parallelism in the context of geography and cartography, so it really kind of, I think, lowers the barriers in terms of introducing it into our education. As a simple example, in 6 lines of Python or PCML code, we can implement things like local sum, which will operate on multiple rasters, adding up all of the values at the individual locations. You can do this on local, focal, zonal, and global operations, and you gain automatic parallelization. So in these 6 lines, you can get that graph right there. So suddenly, with very little introductory material with Python programming and cartographic modeling, we can transition almost instantaneously into parallel programming. So for my fellows' work, I have 3 key deliverables, which you can't read the bottom ones, and that's okay. So the first is a well-documented PCML implementation. So we've been talking about tools a little bit and the lack of tools, particularly for education, and I think that most of the tools that are developed for research rather than teaching. And generally, tools that are developed for research are not well documented, I'm going to argue. Including my own code, I'm guilty of it as well. But one of the key things here is I'd like the code to actually be easy for a student or an instructor to download and for them to actually just get up and going very easily. And then 8 lessons, it'll probably grow to more. It'll represent the first few weeks of my CyberGIS class in the spring, targeting Python programming and cartographic modeling. This will really lay the foundation of the concepts. And then we'll talk about parallelism, speed up, efficiency, Amdahl's law, in the context of cartographic modeling and what the students are already familiar with, right? And then we're going to get our hands dirty with CI-enabled big spatial data processing. The students will either get on the cluster at Kent or potentially some of the supercomputers through Exceed and actually be able to process some of the big spatial data using the concepts that they learned in the earlier modules. And then the third, you can't really read it. I also added interactive mini modules. So one of the changes in my CyberGIS class in the next year is going to be that it's a hybrid class. It's going to be part online, part face-to-face. One of the challenges is when you're teaching these complex concepts, I'm a whiteboard drawer. So generally what I'll do is I'll get up on the whiteboard and talk about it and work through it, you know, asking questions and everything else. But then you're challenged, if it's an online class, how do you do that? These interactive modules, you can't see it at the bottom. I was really inspired by data-driven documents, D3. It's a JavaScript framework, and it really adds an element of interactivity to websites that I think is quite powerful and could be reproducible and really reinforce the learning process. So I'm going to deliver a short course of the material in early fall. I was actually going to do it this summer, but some of the students disappeared, and we have some new students coming in that I think are interested. And those that are too scared to take my CyberGIS course, I think that I can convince them to take at least a short course and kind of introduce them to the material. And then I'll incorporate it in my CyberGIS course, distributing it through Creative Commons, so for free for everybody. And I'm actually glad Dan Katz introduced HPC University because I was chatting with Scott Lathrop, a good friend of mine, who is kind of one of the organizers of that. And this is a community of computational scientists and computational science educators that are actually interested in the domain aspects, right? So they're thirsty for applications. And I think that this is something that CyberGIS can actually give them. They're hungry for it. So I think that in terms of professional development, I think that this would be a good area. And then the PCML code is already freely available. Thank you.
Hi, I'm Terry Slocum with the Department of Geography, University of Kansas. My colleague is Xingong Li, also with the Department of Geography, University of Kansas. The title of our project is Developing Material for the course Mapping and Analysis in the Cloud. And what we're going to be doing is teaching students programming, undergraduate and graduate students. I've underlined mapping because that's my strength, cartography, and underlined analysis because that's Xingong's strength. He's spatial analysis and programming. One of our motivations is the range of existing map mashups. This one is from Dustin Cable's racial dot map. And if that's a little bit difficult to interpret, that's actually desirable because one of the things I want to do is get students to develop their own mashups of this sort. And one of the issues is, how do you go about doing that? If you right-click on the previous image and select open source, you see the code that underlies that particular application. Of course, this is just a small fraction of the code for this particular application. So our key question is, how do we get our students to write that code? Would be one of our motivations. We also have an analytical motivation. We see increasing data with limited storage and limited computational power of standalone computers. At the same time, we see people doing global scale data analysis. Example of that is the collaboration between Google and the University of Maryland to produce a Landsat forest change analysis, which I'll show in the next slide. Another thing that we see is high temporal resolution. For example, Xingong is tracking storms from radar observations. And finally, we also see spatial algorithms that take advantage of cloud computing power. So these kinds of developments lead us to two key course objectives. One is to introduce students to spatial big data problems. And the second is to introduce students to a range of tools for tackling those sorts of problems. This is the global forest change slide that I mentioned in the previous slide. Over 500,000 Landsat images were used to create this. Now, I don't expect our students probably to do something of quite that magnitude, but we'd like to move, say, in that direction. Another motivation for us is Michael Peterson's new book called Mapping in the Cloud. It doesn't exactly fit our course because you notice the title only includes mapping. It does not include analysis. Another limitation, this book is written for a student who does not necessarily have any programming background. We are assuming a prerequisite in our course of an introductory programming course, right? They have to have a programming course before they come in. So our target is, I would say, a little bit above this book, but this is a good starting point. It's one of several things that we'll be making use of. The major topics that we'll cover in the course, the first two overlap my interests, traditional thematic mapping, but doing that in the cloud. Also animated mapping, but doing that in the cloud. We'll be using computer code to do that, so students be writing in, say, HTML and JavaScript. But also, there's a fair amount out there that does not necessarily involve any programming. For example, last week I attended Google's Higher Ed Summit, and they taught us something about Google's Earth Engine Tour Editor, which allows you to create very impressive map animations without writing any computer code. Xingong Li has an interest in analysis of spatial temporal data in the cloud. For example, he's interested in examining global snow cover trends and having students take on that process. Some of the tools that we'd like to use and associated APIs would be Google Earth Engine, Microsoft's Azure, the CyberGIS tools, of course, that are associated with the CyberGIS Center, and Hadoop. Finally, we're also interested in virtual reality in the cloud. I've had long experience with stereoscopic displays. And so what we've done is purchased 2 Oculus VR headsets, and we're going to integrate those in with Google Street data and data from here.com. So we haven't done anything with that yet because we don't have the headsets in-house yet, but I think students will find that exciting. Our student evaluation will consist of 3 parts: attendance and participation, 10%, probably approximately 15 programming exercises, and then the final project, what I think would probably be the most interesting part of this. My vision, and maybe this is too much, is to have students develop projects whereby someone would say, did you see that interesting application that a student at the University of Kansas developed that might compete with the racial dot map that we saw earlier? And the deliverables, obviously, all of the lecture material, all of the exercises that we develop will be provided. But as I think about that, how we're going to teach a class like this, it is not going to be just PowerPoints. There's going to be a lot of interactive demonstration of programs, and that's going to require some discussion as to how that takes place. And that led me to think, okay, what we really ought to do is also write an article describing the full course development, the evaluation of the course, probably submit that to Journal of Geography. I did something similar to this about 20 years ago, believe it or not. When I was teaching Visual Basic, I submitted an article to Journal of Geography. So I have some experience in that area, but I think that would be a potential outlet, in addition, of course, to the CyberGIS Center. And then lastly, we would, of course, with students' permission, provide all student exercises and final projects. And I think that's it for me. Thank you.
All right. My name is Jie Tian from Clark University, Worcester, Mass. First of all, I'd like to, it's a great honor for me to be in this class, the first class of CyberGIS Fellows. And I want to thank the CyberGIS project committee for giving me this opportunity of being here and joining this exciting and collaborative effort of promoting CyberGIS education. So, I like to start my talk by highlighting the broader background and motivations for me to propose this project in the first place. So as we can see more and more, traditional software is transforming into a new model, that is software as a service. And big data is collected, generated, high velocity, large volume, with very rich variety. In response to the needs created by software model transformation and handling big data, I think cloud-like storage and high-performance computing come to the stage as the solutions. Against this background, I think GIS has been evolving and adapting in this new cyber environment. Like the leading players in the GIS industry and the leading scholars in the GIS science research community has been thinking and working very hard, addressing the grand challenges and opportunities that GIS is faced with. So so much progress has been made, as you can tell from the presentations, talks, and discussions in the past 3 days. What about CyberGIS education? I think many of you would agree with me on that. CyberGIS education is somewhat left behind. Taking GIS curriculum at Clark, for example, we offer the following courses. And as you can tell, CyberGIS is missing. But it is highly demanded. That demand is largely driven by computational challenges or even failures encountered by not only students, but also faculty members, researchers on campus. So I want to thank the project one more time. I think the opportunity has come to make a change. Okay, the question is how to add CyberGIS. My proposed strategy for adding CyberGIS into the curriculum is to develop lightweight course modules that can be plugged into teaching existing GIS courses or combined together to form new courses, like CyberGIS, for example. Because CyberGIS is so complex, as you already appreciate, I wanted to place my focus on the computation side, geocomputation. In the design, since this is a conference of CyberGIS geodesign, so I figured it would be fair for me to talk about design, although it's a course design. In my design, there will be 3 course modules. There are going to be a theoretical module, practical module, and a technical module. So the first module is about fundamentals of CyberGIS. Those are the tentative topics. For the sake of time, I'm not going to talk them through. Objectives of the first modules are to really seed interest of learning CyberGIS among students, and to hopefully attract educators with similar teaching interest to adopt the module into their next effort of course development, and to advocate for big geospatial data-driven research with CyberGIS. And the second module is about CyberGIS platform and software. Again, those are tentative topics. The second module should serve to get students familiarized with the CyberGIS software ecosystem. And hopefully, they will appreciate the value of CyberGIS in performing big geospatial computation. And very importantly, I would encourage them to rethink the classic geospatial analysis in the new context of CyberGIS. Third module is about really high-performance geocomputing. So those are the topics. And the third module is designed to include parallel computing into the training of GIS programming, which is currently not covered, at least like the programming teaching on Clark campus. And I also wanted to help students solve their geospatial computing problems. And lastly, I wanted to help grow the CyberGIS developer community, hopefully. So what to deliver? Oops. All right, that went too fast. As you can imagine, like, I'm gonna deliver like well-documented, detailed lecture notes, and compile the lists of readings, and like well-developed lab exercises, especially for high-performance computing topics. And in addition, I'm hoping to get some related research down. So, like, forgot who said it would be always a good byproduct, right? With that, thank you. I'm really excited to be part of this cohort, and I look forward to learning very much from you guys. Thanks.
Thank you. And my name is Chuanrong Zhang. I'm associate professor at University of Connecticut. I hold a joint appointment between Department of Geography and the Center of Environmental Science and Engineer. And my project is try to improve current WebGIS course to enhance CyberGIS education at UConn. So CyberGIS represents many new cutting-edge concepts and technologies. And in the last 2 days, we have many very exciting presentations, and big progress has been made in CyberGIS. Many new tools have been developed. However, the education material is not too much. So the objective of this project is try to add some new concept and new tools to the current WebGIS course, so can let the interdisciplinary student, undergraduate student, and graduate student to learn the new CyberGIS. And just give you a little background about the current WebGIS at UConn. And the WebGIS course, the main objective is to try teach students some very basic WebGIS technology and tools to let them develop some web-based GIS application so they can find a non-academic job. So currently in this class, we mainly teach really very fundamental WebGIS like HTML, HTML5, JavaScript, and we also teach software, Microsoft Expression Web, let students design a web page. And we mainly teach ArcGIS server and teach students how to customize ArcGIS server with JavaScript. So these are very basic WebGIS knowledge. And really no new CyberGIS theory or the practice. And for objective of this course, we just try to, add some new materials to the current WebGIS course. So basically, I want to add some contents related to the concept and the theory behind CyberGIS. And I also want to add some CyberGIS technologies, such as distributed GIS service, geospatial semantic web, and cloud computing. And add some new lectures and lab modules to teach students which CyberGIS capabilities and service provided by CyberGIS Center at UIUC. So, but this also has some issues. As several of my colleagues mentioned, now the technology really constantly keeps changing. And I just remember 6 years ago, when I taught in Kent State University, I taught the WebGIS. At that time, I except HTML, JavaScript, the basic thing, no change. But at that time, I taught front page, ArcIMS. But now, these software not available. So the WebGIS, the main challenge for a faculty is it changes too fast, and you have to always learn the new things. And for me, like part of my research is geospatial semantic web. But CyberGIS has so many technologies like cloud computing, and I don't know, I have to learn myself. I won't talk about the detailed plan, how to add the new lecture or lab materials. All the developed new materials will be shared with the GIS community, and I will be very happy if they can be used by other colleagues.
So this is the final presentation, and Karen will summarize and synthesize, I guess.
My goodness. So I'm a fellow too, like all my colleagues down here. And my proposal is very different. So just to put that all into perspective, Dan's presentation this morning, he set us up really nicely because he talked about the education programs that have been happening through the computer science community and how those, we need to build the community who is going to get behind this. And this program, when I saw it, the solicitation, I thought, wow, this is exactly what was needed. Something to move the community forward. But I also felt when I saw it that 10, 14, 15, whatever the proposed number was, of little bits of all cool stuff, how do we get that into the community? So I thought, well, I think I've done this before, and I think that my role in this exercise can be to help take all of this and working together and trying to make it look like a whole rather than a bunch of little bits, and have something to put out into the community to engage the whole community who are ready to jump in to teach CyberGIS, just as we did 20 odd years ago with the GIS stuff. And we already have this experience in the GIS community side of pulling the group together, getting a bunch of people who are on the front edge to think about how we teach it, and then getting that language and that material and all that infrastructure, education infrastructure out there into the community. So my job is to help disseminate and move this out into the community, and also to make sure that what we put together looks like a whole and not just a bunch of little bits that people are going to have to find their own way through. So I like the idea of seeing all these really interesting different bits, pulling them together, and there's going to be a lot of connections and linkages, and the relationships between the different modules versus the different course structures versus the bigger thinking about how we actually do this kind of education. There's lots of neat stuff that's going to be here, and I'm very excited to see how we can just tie this all together into something that people will come to and say, aha, I can get started, I see it. So that's my little pitch at this point. Is there anything else you want me to say now, or